All right, this is Mr. Wyrick, and I'm going to go through the 3.9 central angles and measures of arcs notes with you. On the second slide, you can see a central angle is an angle whose vertex is on the center of the circle. Nice and simple. You can see on the left-hand circle over here, we've got a 145-degree angle, we got a 165-degree angle, and then we have an angle that is X. All the way around the circle is going to be 360 degrees, just like you would expect. So 165 and 145 should leave us at 310, which would leave us 50 left for our X value. On the other one, we've got a 90 and a 40, that's 130. And then we add to that 85, so that's 225. So 225 subtracted from 360 is going to put us at 135. Okay, so on the next one, we've got some definitions of stuff here. The arc is a portion of a circle that's defined by two endpoints. So you can see we have arc AB up here, and then we have another one that we could kind of call arc AB. This is the difference between the minor arc and the major arc. If you just say arc AB in this case, we're going to assume that it's the minor arc. It's the shortest distance between those two going around the circle. So if you're going to say the major arc, you usually need three letters. You would say arc ADB or arc BDA. That would include that point D, so we know we're going through that on the way to the other. If you do a semicircle, semicircle is half the circle. So if you say arc AB and it's a semicircle, we don't know if you're doing the top half, the bottom half, the left part, the right part, whatever. So you need to make sure, again, when it's a semicircle, that you talk about 3 points, okay? So ADB would be a semicircle, or AB the other way. We don't really know. We might need another point on that one. On the next slide, it says PM is a diameter of circle R. Identify each arc as a major arc, minor arc, or a semicircle. Then find its measure. So MQ, that's going to be a minor arc. Okay. And out of 180, we've got 115 already. So that should be a 65-degree arc, just like it would be a 65-degree central angle. The central angles and the arcs share the same measure, so it makes it a little easier. MNP is a major arc or a semicircle, and MNQ is also going to be a major arc. The semicircle should be 180, and then that major arc would be, well, if the small one there was 65, it's going to be 295. Congruent arcs. The main thing I wanted to say about congruent arcs is if we have vertical angles across the center of the circle, those are going to be congruent angles. So the arcs formed by those are going to be congruent. Adjacent arcs, remember, they don't have to add up to anything. So just make sure you understand how to subtract and add on those. And just like any kind of number, arcs can be added and subtracted. On our last example here, what would be the measure of arc CE? You can see CA is a diameter, and a diameter minus 63 would be 180 minus 63. That's going to be 117. And then arc ABD. If we look at the short distance from A to D, that's 90 and 63, which would be 153. So we would just subtract that from 360 to get that major arc, and that'll give us the measurement that we need. Hopefully this helps you out, and the paper today should be pretty easy. Good luck.